the function opens upward, and at 0 comma, I don't know, we can put in any number we want. So at 0 comma this number, it has a relative minimum, opening upward and decreasing. Fine. Then it starts increasing, and this is at 2. Because it starts increasing, and the limit of the rate of change is infinity. Then on the other side, so I can put here infinity and negative infinity. Not for the function, but for the derivative. Okay, on the other side, so see the rate of change, the limit is infinity. Okay, on the other side. On the other side, it's coming from negative infinity. So it's this. Going to 4 comma something, 2, 3, 4, where it has an inflection point. So opening up. At this point, it changes concavity, opening down. It was a very interesting problem. Thank you for picking that. So x equals 2 is a vertical asymptote. I hope you understand and you agree with me that this is impossible. Impossible. I hope you agree. Now, dissecting and analyzing each and every item and putting it in the table helped us come up with this. So the limit of the rate of change here is positive infinity. But the limit of the rate of change on this side, look what happens here. So on this side is going to negative infinity. It's a negative slope. And it's going to negative infinity. Awesome. Questions? How do we feel about the table? That's what we've been doing. So we're getting closer to graphing. How do we feel about the table? Anyone, please say anything. Are we okay with the table?
Yeah.
Yes.
Okay. So now we are ready to graph. Not rational functions yet, because I would like to talk about asymptotes. So we are ready to graph now. Still somewhat simple examples. So 45 through 58. Now we are putting everything together, and we are also graphing. Here we had no choice. This was an example of a graph. But now we're going to start with another example from the beginning till the end and also graph it. 45 through 58. Intervals of increase, decrease, max, min, intervals of concavity, and put everything together and sketch the graph. So we are ready now. Anyone would like to choose? If not, I will.
$53.
53. Very good. 53. This one with the radical? Is that the one?
Yes, because
Very good.
I hate radicals.
Okay, perfect. F of x equals x, the square root of 6 minus x. Perfect. So in this problem, we do everything that we've done so far, including the table, plus graph. Great job. I'm going to make the table as big as possible so that I don't have to redo it because it's squeezed in there, but who knows? It's okay. It's not a big deal. I can remake it from scratch anytime. Okay, let's look at the function. What is our first step? Mandatory forever and always.
Differentiate.
The first step. Forever and always.
Differentiate.
Forever and always. I must start here.
The domain.
Excellent. Great job. Good. That's my first step. I don't care about anything else. I have to put the domain in first. Great job. Good. Then what do we do? What do I have to write for this function? What is the restriction? How do I solve it? What is the potential problem here?
The x has to be greater than or equal to 0?
Careful.
Greater than 0?
Careful. What are we looking at? What could be the problem here? X is not the problem here.
Well, we can't have a negative.
Exactly. Exactly. So what do I have to write? I have to write something. Don't solve anything. I have to write it so we see it and then we solve it.
Oh, are you talking about when we write like equals 0 equals undefined?
This is a radical function. This is not a rational function. What is the restriction for a radical function?
It can't be negative.
Correct. So what do I write? What do I write? When I say it cannot be negative, what do I mean?
Oh, the square root of 6 minus x?
Not the square root. Not the square root.
Is it just 6 minus x?
Yes, just 6 minus x must be
greater than 0 or equal to 0.
Exactly. That's the restriction for this function. So I have to move 6 to the other side and divide by -1. So that's our starting point. That's how when we put everything together, 6 minus x greater than or equal to 0, negative x greater than or equal to -6, what do I do now?
Divide and flip the sign?
Yes, I divide both sides by -1, and I get
X has to be less than or equal to 0.
exactly.
Or sorry, 6.
Exactly. This is the domain, -infinity to 6. Now I can start my analysis. That's the crucial step. Awesome. Great job. Good. Now, I need to know what happens here. And I need to know what happens here for the function. First, domain. Then I exhaust the function, limits or values, and x and y intercepts if they exist. Only when I finish with the function, I move on to the derivative. Awesome. So let's plug in 6. When I plug in 6, how much is f of 6?
0.
Excellent. 6 minus 6 is 0. 0 times 6, 0. Now we have to find this limit. So when x approaches -infinity, where is this going?
To infinity?
Yes. So the square root of infinity is, because I have to apply the square root. Who cares? The square root of infinity is exactly infinity times -infinity. How much is infinity times -infinity?
Negative infinity.
Absolutely awesome. Great. Also, I have to plug in 0. Can anyone tell us when we plug in 0, what do we get?
0.
Exactly. So this function is 0 at 0, and it's 0 at 6. This happens to be x and y intercept, and this is an additional x intercept. Now I can say I'm done. I'm done with this. Now I move on confidently to the first derivative. Good. So stop me if you have any questions. I'm going to copy x, the square root of 6 minus x. Perfect. Which rule applies here? So I know how to, yes. First function prime, 1. The square root of 6 minus x plus the first function times, who can help with the square root of 6 minus x prime? I have to put it here.
One over 2 times the square root of 6 minus x.
Perfect so far?
Times the inner function prime,
Which
would
is?
be -1.
Excellent. Perfect. So then I have the square root of 6 minus x over 2 the square root of 6 minus x. What is the least common denominator? Oh, there is only one. What do I need to multiply the top of this first fraction by?
The denominator.
Exactly. 2 the square root of 6 minus x. 2 the square root of 6 minus x times the square root of 6 minus x will be
2 times 6 minus x.
That's it. Minus x. Awesome. Great job. So this is 12 minus 12x minus x. 2 times 6, 2 times -1 minus x. 2 the square root of 6 minus x. So I have 12 minus 3x. I don't like it, but now I do. I pulled out a -3. -3 times x is -3x. -3 times -4 is 12. This is how I want it. And it could be 0, or it could be undefined. Okay, perfect. If this is 0, how much is x? If this expression is 0, what could x be? Anyone, please?
Four.
Of course. Back to the table right away. If this expression is undefined, what could x be? What could x be for this to be undefined? Anyone?
Wouldn't it have to make it a negative?
It cannot be negative because of the domain.
Right, I thought that's what would make it undefined. No.
but there is one more that is in the domain.
At 0? Or, sorry, 6?
Exactly. 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 So here's this function, is the first time we've seen this, has two critical numbers, one coming from f prime being 0 and one coming from f prime being undefined at the value where the function is defined. Good. All I need to do now is study the sign of the first derivative. This is the first derivative. I refuse to study the sign of the denominator. Why? Can anyone explain why I refuse to study the sign of the denominator? What type of number is the square root? The square root of 4, the square root of 15, the square root of 25, the square root of 100. What type of number is the square root?
Do you mean like in terms of positive and negative?
Exactly, because you are studying the sign. Yes, of course. Exactly. That's the reason why I refuse to study the sign of a positive quantity. Excellent. Great job. Now, the only quantity that gives us the sign is negative x minus 4. Negative x plus 4. We are studying the sign of negative x plus 4. When I plug in 0, 0 minus 4 with negative in front. 0 minus 4 with negative in front. What will the sign be? Negative 4 times negative 1. What is the sign?
Positive.
Yes. Between 4 and 6, I'm going to put in 5. Again, I refuse to study this. How much is 5 minus 4 times negative 1? I only need the sign. 5 minus 4 multiplied by negative 1.
Negative.
Yes. This is the moment of truth now. This is when I find all my mistakes. If these rows do not work well together, then I have to go back to the drawing board. So hopefully we don't have to. From negative infinity to 0, what does the function do? From negative infinity to 0. Oh, of course, I forgot to plug in. I have to plug in this. So 6 minus 4 is 2. So 4 the square root of 2. 4 times the square root of 2. 5.7. Good. So from negative infinity to 0, what does the function do? Anyone? I'm sure everyone knows that from negative infinity to 0, the function is increasing. Is that supported by the sign of the first derivative? What does it do from 0 to 5.7?
It still increases.
Yes, supported by the sign of the first derivative.
Yeah.
And from 5.7 to 0, what does the function do?
It decreases.
Good. Is that supported by the sign of the first derivative?
Yep.
Yeah. So these two are okay. Finally, the second derivative. Not friendly at all. The first derivative wasn't friendly. Look at the second derivative. So I'm going to copy the first derivative,